going to try to record this Momentum Lab for everyone. And it'll be kind of interesting because we're going to move our camera around quite a bit. And it's so hopefully nobody gets seasick from that. If you would go ahead and make the copy, find in the lesson, we're going to scroll down. We already watched the clip. Make a copy of this Google Doc, and we'll be submitting that as a PDF when we're finished today. Okay, so in this Google Doc, you're going to go File, make a copy, put your name on it, hit OK. Okay, I'll give you a couple of seconds to do that. No, I should see that coming up. Yep. Okay. Okay, so let's look at our instructions. The procedure here, we're going to take the mass of the car, so we'll find that first. We are not going to remove its seat. I will show you what that looks like momentarily. But use one book to create an incline, and then we're going to change that up as we go along to have 2 books and 3 books. We're going to clock our time to drive a certain amount of space. We're going to complete 3 trials, and then we're going to repeat the steps. So it's kind of straightforward. We're going to end up putting numbers in here, but let's go ahead and get the mass of our car. So we'll go to our camera. Hopefully we can see that pretty well. Not quite, but you might actually be on screen. Okay, so here's our scale. Here's our little car with its little seat on it. Okay, we can see that we have 38, and it says grams. So we will go back to our mass, and we're going to just put 38 grams in there. Now, we can see that grams is already listed in our data table, so we don't need to put it in there. And we're gonna use the same car every time. We can go ahead and just add 38 each time to each of the boxes. And honestly, we could go ahead and put 38 all the way down because we're gonna use the same car every time, and it's not gonna change its mass at all. Okay. And there's 4 boxes. So this kind of add it. Probably even go Control E and this Control E. Now we can put 38 in the average. We probably need to talk about that just for a second, because if it's the same number every time, if I add it up and divide by 3, I'm going to get the same number just because we haven't changed. We'll have to change. We'll have to actually calculate average for time. Okay. So then there'll be analysis questions at the end that we'll discuss as we go along. So let's scroll back up and look at our first data table. We have time, distance, and it does say clock the time your car will go for the full 1 meter. So if we look at our camera, okay, hopefully you can see when I move the scale. Okay, right here is 1 meter on the floor. So we are gonna use our stopwatch that we have here in order to calculate that. So we'll probably move it up so that we can see. Right there looks good, right? Hiding students. Okay, so let's look at our data table and make sure we have it what we're looking for. Time, distance, and then we'll calculate these things. So we'll go ahead and get started with that. All right. And let's see if I can. might need an extra finger. All right. So we're going to put our car at the top of the ramp. Okay. I'm going to hit start. 1, 2, 3, 3, go. We did not pause it at the right time. We'll give that one more try. All right. Reset. Ready, set, go. 1.856 seconds. Okay, so we'll go back to our data table. Thank you. We'll go back to our data table and put in this is, 1.856 seconds. So 1.856 seconds. That's our first trial. And our distance was 1 meter because we stopped exactly 1 meter. Again, we could go ahead and have distance as 1 meter every time because we're going to have the same distance. Okay, so we'll try our trial again. Okay, we're going to go reset on our clock. Okay. 1, 2, 3, go. 1.736. So how do you think we need to do it 3 times? Why do we need to have 3 trials? Okay, so we have increased accuracy. Where could we be losing accuracy? We don't have to be nice about it. I'm not going to click the button exactly the same amount of time every time, right? So all right, let's try our 3rd trial, and then we'll figure the average. Okay. So we need to reset it. 1, 2, 3, go. And we got 1.76 seconds. 760. All right. So how do we do an average? You remember? Right, add them up and divide by the number of numbers. So let's go ahead and do that here, and we'll get our average time. So 1.784. Right. I think we're going to kind of do a bargain basement on this. I am going to say that we just probably need to do the average. So let's just fill that in. All right, so if we do average velocity, we're going to go distance divided by time. So we're going to say distance divided by time. Fill up our calculator. 1 divided by 1.784 equals 0.5605. Okay. And that would be meters per second. So we should probably put our unit, because there is no unit at the top of the data table, meters per second. Okay. So acceleration is the one that we did yesterday in class, the calculation that we did yesterday in class. And so we have that same formula, final minus initial over time. And in this case, we're told the initial velocity was 0 meters per second because we were sitting still. So let's pull up our calculator and calculate that. So we'll have the final velocity is this number, 0.5605. Pull this over so you can see. Minus 0, so we really don't have to do that part of the calculation. Anything minus 0 is still itself. And we're going to go the same time, divided by 1.784. Now, let's get that back up here. 0.3142. Okay. Why are they different? Why are these numbers different? Okay. All right, so she's saying one of them is just velocity, average velocity. One of them is acceleration. Now let's take those words and digest them a little bit. If I have an average, you guys just told me that the average is the add up the numbers and then divide by the number of numbers. This average velocity is over the entire course of time. We're giving this is the velocity for that time. But was the car going the same speed, the same velocity throughout the entire almost 2 seconds? No, it wasn't. Okay, there was some acceleration in there. It had to take a minute to get to the speed, and then it could have even slowed down a little towards the bottom of the ramp. So we can tell these numbers should be different because it wasn't going the same speed at the same time. Okay. Now let's look. This is our new calculation today, and we're going to spend today and tomorrow talking about momentum. But momentum, as we saw in the video earlier, has a lot to do with mass. Okay. So we're going to take, nobody knows why momentum is called P. It just is. Okay. But P equals mass times velocity. All right. So we're going to come back and get the mass of the car times the velocity, and that's our momentum. And we'll discuss that here in just a second. But let's pull up our calculator and get that calculation completed. Okay, so mass times velocity. So we had 38 grams times 0.5605. Okay. All right, so our momentum for our little car is 21.299. And then what is our unit for momentum in this case? We had to do mass, so we had grams, and we multiplied by velocity, grams, meters per second. So for every second, for every second, there's going to be this much force. Momentum is a force that we're putting. Okay. All right. So now, one little car can produce this much momentum. Let's make some predictions. We had a one book incline on this. What do you think is going to happen when we have a 2 book incline? You think it's going to hit harder with more momentum, maybe? Okay. Well, let's use that prediction, and we'll go ahead and try again. So I'm going to I'm going to let you have a chance to fill in the data table, and I'm going to put the second book in our stack. Okay. All right. So we're going to do 3 trials basically for time. We know that our distance, we're going to cut it off at 1. Making the distance 1 also makes our calculations a lot simpler. Not 4. 1. Okay. And let's look. All right. So we're using the same car. We're using the same ramp, the same distance, but we need camera. All right. And we need our stopwatch. Reset it. Reset, go. Let's try that again. Yes, sir. All right, so ready, set, go. All right. So our time is 1.489 seconds. Let's go ahead and put that on our data table. So our time was shorter. What's true about the car? Was it going faster, slower, or the same? It was faster. If our time was shorter, then we were going faster. Okay, we'll try again and see if we get a consistent result. I'll let you get that number on there. Camera, stopwatch. All right. Ready, set. Well, thank you. I'm moving around so much. All right. Ready, set, go. All right. 1.664. We'll go to our data table and put that on there. Okay. Do one more trial, then we'll do some math. Okay. Ready, set, go. 1.289. All right. Thank you. That was the fastest one yet. And remember, could be my error. It could be the when I'm clicking it. It's a human error. That's one reason we have to do averages when we do trials, because we are just human. We are not perfect. So let's go ahead and get this average done. Go clear out that. So add up the numbers and divide by the number of numbers. $1.4, I don't remember what I said. 0.4806 or 81. Okay. So again, we're gonna kind of make this faster. Okay. So we'll just do the averages here. We're doing average velocity, same concept. We're gonna go meters per second. So distance divided by time. 1 divided by 1.31. So 0.6752 meters per second. We went faster. There's more meters per second, so we were going faster. We can see that from the time, we can see that from our calculation, so that one kind of makes sense. Is your acceleration going to be faster? What do you think? Let's calculate. So again, our initial meters per second, our initial velocity is 0. So we're going to say final velocity minus 0 is final velocity, and we're going to divide it by our time. 0.4559. I'll just copy this right here. So our acceleration was faster, our velocity was faster. What's going to be true about our momentum? Stronger, maybe? Higher momentum? Because if we look, mass times velocity, I have the same mass, but I have a greater velocity. So my momentum, my force, should be bigger. Let's make sure that makes sense. Okay, so 38, which is our mass, times our velocity, which is so in fact our force is greater. So 25.658. We will once again just copy our units. Okay. I think we'll skip the $3, but yeah, let's just go ahead and skip the last two. We'll go ahead. This is not as fun when I'm doing this as when you guys get to do the lab yourself. But we kind of get the idea. When we see that the velocity was higher, then the momentum is also higher. Okay, let's go ahead and talk about, so we'll skip those two parts right there. Let's go ahead and talk about these questions here. Let's say that, and let's make them bigger so you can see. Okay. What is momentum? Momentum, we come back and look at our data, look at your numbers so you can use that as evidence in your answer. Momentum is mass times velocity. So mass is the amount of stuff, your matter, times how fast you're going. Now think about that. If you have a great big guy on the football field, he's running really fast at you, are they going to hit you hard? Yes. Okay. Or a car. Think about the road. Is a semi truck that's going really fast going to hit harder than a semi truck that's going really slow? Yes. Okay. So let's go ahead and put in momentum is mass times velocity. Okay, and this is a thinking question. How would momentum change if mass were added to the seat of the vehicle? So if we put like a weight in the little seat of our vehicle, would momentum be greater or less? Greater. So again, if we think about those cars again, if I have a little regular sized truck going really, really fast and a semi truck going really slow, we could have the same momentum. Okay. So the more mass that I have, the greater momentum I'm going to have. more mass would be a greater momentum. And we should probably capitalize the first letter of our sentence. Alright. Then this one, I guess I should wait for you to type, shouldn't I? All right, so this one, when you calculated velocity, the column title says average velocity. Why does it say average velocity? There was a little bit of time there, and the velocity could have changed between those few moments. So that's your answer. Probably. Be nice if I could. Okay, 4 and 5 I'd really like for you to do on your own. Which setup had the greatest momentum? Explain why. And which setup had the greatest acceleration? Explain why. So you kind of think about that incline. Why is it? Why was momentum greater? Okay. I'm going to give you a few seconds to go ahead and do 4 and 5, and then we'll talk about 6 in just a moment. Number what? More mass would be greater momentum. So let's talk about 6. Which setup would cause the greatest damage in a car crash? To go back to our data, okay, momentum and force, which one's going to cause the greater damage? The second one, and notice the velocity. So when we go faster, we create more force, we're going to create more damage. Okay, because that greater force can overcome more opposing forces. So go ahead and answer that in your own words. So set up talking about momentum. If we have a greater momentum, a greater mass, or a greater velocity, we're going to cause more damage. Give you a couple of minutes or 8 seconds to answer that part. The last one is probably the most important question. We're going to look at it a lot, but compare and contrast the momentum formula to the force formula. So if we look, momentum is mass times velocity. Force is mass times acceleration. So they both depend on mass. They both depend on movement. We know that acceleration involves velocity. Okay. But we can see that they are very similar formulas because they're both talking about movement. They both rely on the amount of mass that an object has. Okay. So go ahead and answer something about that. Okay. And then when you're done, you're going to say File, Download as a PDF. And you're going to submit that PDF to today's assignment. Okay. So hopefully you can get that